Assalamualaikum, I'm your teacher Rehan Tareen and I'm back here with the new lecture of Physics Class 9th. We are having our chapter 2 and topic is 2.5 this time. Before starting this topic, we'll be having a short revision. We studied about the scalar quantities, the vector quantities, terms associated with motion, velocity, speed, distance, etc. Now, there I told you about one thing, that was the graphical representation of vectors, if you remember. It is represented by an arrow with a head. So, when we represent a vector graphically or when we are representing the terms associated with motion graphically, so that is known as graphical analysis of motion. Actually, in this topic, we'll be having a comparison between two quantities in the term of graphs. So, there are two types of graphs we'll be studying in this chapter. One are the distance time graphs and one are the speed time graphs. So, first of all, what are distance time graphs? Distance time graphs are those graphs in which we study about the relation of distance and time. If you do remember, there was one quantity which had the formula of V is equal to distance upon time. So, V is equal to distance upon time was the formula of speed. Here we are studying about the relation of distance with time. So, distance upon time, actually in this graph we'll be studying about the speed, that how we'll be finding out the speed and we'll be gaining it. So distance time graph, how we have three conditions here. Number one is when an object is at rest, then how will be the distance time graph, how will be the slope of line, how will be its representation. So before going at that, I'll be telling you that in graph, where do we keep on the, what do we keep on the horizontal axis and what do we keep on the vertical axis. So before this, I'll be telling you about a Cartesian plan, which is a plan which you'll be studying in your mathematics chapter number 8. It says that the straight line always shows the y and the perpendicular line always shows x. So one thing here is that we'll be having four variable quantities being used here. So the upper one will be y, which will be plus, and the downwards will be minus. Then the right side x will be plus and the left side one will be the minus. When we get a value of x and it will be in minus, we will be representing on the left side, and if we get it in plus, we will be representing it on the right side. Like the same, in the y case, we will be having, if value is in plus, so on the above side, and it will be negative, so on the downward side. So here, if we just take these two sides, we skip these two sides, it will be a positive y and a positive x. Mostly we ignore the negative x and y in the physics. While we'll be studying anti retardation, because as I told you, it's a negative acceleration. Where the things are negative, then we'll be using the negative variables too here. So the thing is that distance will be shown on the vertical axis. Means if this is a graph, so distance will be shown up here. It will be meters. Meters is the SI unit of distance. And on the horizontal axis, means on the x-axis, we'll be having time, which SI unit is second. So here, as I've shown you that in object at rest, it is a distance time graph. The distance will be at the vertical axis, which is y, and the time will be at the horizontal axis, which is x. So if we look at it, so we are having points which are 5, 10, 15, 20, 25 and 30 the meters. And now here is one common point in all the graphs, which is the origin point, O point or 0 point, where everything acting there is said to be the 0. So in object at rest, it means that object is stationary, it is not moving. While one thing it should be there, that if an object is stationary, for example, it's kept here, the object is here, it is not covering distance, it is at rest, it's not covering distance, means it is at the same point. It is not covering distance, but time is passing. As we know, time does not wait for anyone, so the time continuously passes and the object is at rest. So the distance will be 0 here, the distance will not change, distance will be at the point 0. But the time will be continuously passing, as I'm showing you the line, that the time is continuously passing, but the distance is not being covered, there is no distance covered. As you can see, if the distance has been covered, so we will be having a comparison between this. A cross-sectional line will be there perpendicular to each other, which will be crossing each other. But here we don't have any line, so the time is being passing, but there is no distance being covered there. Now one thing, when we'll have the distance always 0, so the line will be parallel to the time axis, means it will be straight to the time axis. And if the distance is not 0, distance is being passed and the time is 0, so the line will be perpendicular to the parallel to the y-axis, and here it will be parallel to the x-axis. So this was object at rest, in which the line will be parallel to the x-axis, means the horizontal axis. So that was our first graph of the distance time graph. The second one is when the object moves with a constant speed. Constant speed, uniform speed. What does it mean? When an object covers equal distance in equal intervals of time, however short the interval may be, then the object is said to cover the possess constant speed or uniform speed. It means that when an object is covering 5, as I told you, that the ratio on the both sides should be equal. If it is 5:10 here, it should be 10:20 there, then 15:30. So as compared to all these ratios are also increasing. Means the percentage of the ratio is being equal in the both sides. So here, when an object is in uniform speed or constant speed, so it will be having a comparison of equal ratios on the both sides. And it means that the distance and the time, they both will be having an equal ratio between each other. For example, if an object is 0, distance is 0, means it is at completely rest, and time is also 0, it has not started its journey yet. So the both things are 0, we will be starting at the point origin, O point. First of all, it will be here. The next point will be when we will be covering up the distance, it will be of 10 meters, and it takes 5 seconds to cover the distance of 10 meters. So then it will be the 10 meters here and the 5 seconds here, so we're making a point perpendicular to the cross-sectional area here. Then if it takes 5 more seconds, so it will cover 10 more meters. So again, 5 more seconds, 10 more meters, 5 more seconds, 10 more meters. When it is covering and the ratio on the both sides is being equal by time to time, then the object is to be having the constant speed. So here the last part of distance time graph, it says that when an object is moving with variable speed. Variable speed means when the ratio on the both sides is not equal. For example, it's taking less time and consuming more distance. Consuming less distance and taking more time means the ratio changes time to time, then it is said to be variable speed. The graph of variable speed won't be a straight slope of line. It won't be like this. It won't be the straight line. How would the line be? It will be, for example, it will be covering 20 meters in 5 seconds. So it will be, the point will be starting from here. It is taking 5 seconds and covering 20 meters. Then it is taking 10 seconds and covering 25 meters, for example, the point here. And then if it is taking 15 seconds and it's covering the 40 meters, so then the point will be here. So how would the graph be? It will be like this. It will go first straight, then curved, and then like this. The graph won't be equal, means the line won't be straight. It will be having a zigzags between each other, and it will be having bumps between each other. For example, it's a bump. The line is not straight, it is having ups and downs in the line, so then it is being called as variable speed. This is our topic, distance time graph. Topic 2.5, graphical analysis of motion, that is speed time graph. Before this, we studied about the distance time graph, in which we studied about the ratio between distance and time. So here we'll be studying about another ratio of two quantities, speed and time. Speed is a scalar quantity and time is a base quantity. So the ratio between, a graphical ratio between speed and time will said to be the speed time graph. It is a very easy topic, it has vast usage. This is used to drive our 3 equations of motions, and I will be teaching you the 3 equations of motion aside of the graph, because graph, you can say it's the type of rectification. I'll be teaching you with the conceptual way. So in speed time graph, we'll be having speed on the y-axis and we'll be having time on the x-axis. So in graph you must remember one thing, that is the origin O. O means the 0 point, which is in O everything is 0. Everything that is on O's line here, on the x-axis, that will also be 0 and on the y line it will also remain 0. So now the speed time graph, we have two conditions in it. Number one is when the speed is constant, means the speed is constant. Constant is a term which means that something is not changing. One is uniform, but one is constant. Uniform means that with the changing of other quantity, it is also changing. Mean the ratio on the both sides remains equal. But here in constant, one quantity is increasing and the other is not increasing. It is remaining at the same point. I'll be giving you an example. For example, a body starts its motion from point A to point B. It has the speed the speed of that object at point A is 4 meters per second. At the middle, it is also 4 meters per second, and at the end, it remains the 4 meters per second. While the time here was 2 seconds, then 4 seconds, and 6 seconds. The time is changing, but the speed of the object is remaining constant. So this is the constant speed of an object, a body possessing constant speed. So how will be the representing it on the graph? It will be like this, that the constant speed will be showing this line. This line will be showing the constant speed. It means that the time on the x-axis, it is taking time. It's taking 10 seconds, 20 seconds, 30 seconds, 40 seconds, as I told you here. But here one thing is common, that the object is not changing its speed. It is remained at the same speed of 10 meters per second for a long period of time. Means at 10 seconds, at the time of 10 seconds, it was at the 10 meters per second speed. At 20 seconds, it was at 10 meters per second. At 30 seconds, it was again at 10 meters per second. Meaning 10 meters per second, 10 meters per second was a constant time, constant speed for it, which was not changing with the time. This is the condition of constant speed of speed time graph. Now the other condition comes, which says that uniform speed, or you can say uniform acceleration here. How does this work? It works like, as I've told you, that what is uniform speed, if you remember, and uniform acceleration, uniform velocity, it was that when an object covers equal distance with equal intervals of time, however a short interval, a time of maybe, it means that the ratio on the both sides has to be equal. For example, if it is 4/8 here, so it has to be 8/16 here, then it has to be 16/32. Means the ratio on this side and this side remains equal. It is changing by the term changing on the other side too. They both are changing at once and they are having a relation between each other. So then an object is said to be having uniform speed or uniform velocity or acceleration. So it means that when an object takes 10 seconds to cover 5 meters per second here, it takes 10 seconds to cover 5 meters, then it takes 20 seconds to cover 10 meters here, 20 seconds to cover 10 meters per second. It is gaining speed and it's also consuming time. At 10 seconds it was at the speed of 5 meters per second, then at 20 it was at 10 meters per second, and then on 30 it will be 15 meters per second, and then at 40 it will be 20 meters per second. Means whenever you see that the graphical line is having a slope, a straight slope, it is not having a slope like a zigzag thing, it is having a straight slope, so that will be a uniform quantity which is accelerating or retarding, or it is gaining speed or gaining velocity. So this was our topic, speed time.